We're on activity, math 151 OER activity 2.2 to 2.4. And today we're going to be talking about equations of lines, graphs of lines, finding the slope of a line, lines, all lines. All right. So first, in a function, the average rate of change, that's the change of the output with respect to the input, is given by the quotient of the change of the output and the change in the input. Notice we use the notation, that symbol is delta output or delta y over delta x, delta input. So the average rate of change, and this is for any function, is the change in the output, delta y, over the change in the input, delta x, okay? If you pick any 2 points on the graph of the function and the change in the output over the change in the input is the same or it's constant, that means we have a linear function. So linear functions have a constant rate of change, and we call that constant rate of change the slope. So this computation here that we have for finding delta y over delta x, for linear functions, that's just computing the slope of the line. That's what we call the constant rate of change. And if you're given 2 points, x1, y1, and x2, y2, to find the slope, delta y means we're subtracting the y's, delta x means we're subtracting the x's. So this would be y2. Let's find a better color to write in. Sorry, red feels harsh today. Let's do purple. We'll do y2 minus y1 over x2 minus x1. This is the equation we use for finding the slope of a line between 2 points. Okay, and again, the slope is the average rate of change of the function. If you see that terminology for a line, we know that average rate of change just means the slope, and it's constant for a linear function. All right, a function f is a linear function if it can be represented by the equation f of x equals mx plus b, or y equals mx plus b, or we're using function notation, so we say f of x. This is called the slope-intercept form of a line. M represents the slope, y2 minus y1 over x2 minus x1, and b represents the y-intercept, or the horizontal intercept, I'm sorry, vertical intercept, where the graph crosses the y-axis, okay? If you have those two things, if you know the y-intercept and you know the slope, you can put those together to find the slope-intercept form of a line. We know how to find the slope if we're given 2 points on the line, and now we know that if we know the slope and the y-intercept of a line, we can write the equation of the line in slope-intercept form. All right, boom, identifying linear functions. So in example 1 here, we're going to practice identifying whether or not we have a linear function from a table, okay? We have a linear function if we look at any 2 ordered pairs here, or any 2 points, and the change in y over the change in x is the same, okay? So use the following table to determine whether the table represents a linear function. If the function is linear, write its formula using the slope-intercept form. Okay, so using the table, if your x values are changing by the same amount, like from here to here, -1 to 0, we see that delta x would be 1, because the x's are increasing by 1. And then from 0 to 1, again, delta x equals 1. From 1 to 2, delta x equals 1. The x values are going up by 1. And then for the y values, well, I don't know what's going on over here. For the first one, I'm gonna actually color code this. Let's look at them in pairs. So delta x for the first 2 points is 1, and then delta y for the first 2 points is, we go from 1 to 0, -1. So for the first 2 points, delta y over delta x, which is the slope, is -1 over 1, which is -1. Okay, in order for this to be linear though, if we pick any 2 points, we should get that the slope is -1. Let's check the next 2, and I'll put them in a different color so it's a little easier to see. Why are all the colors being weird? Okay. So for the next 2 points, if we go from 0, 0 to 1, 1, delta x in this case is 1. The x value is going up by 1. Delta y is also 1. So for that one, delta y over delta x is 1 over 1, which is positive 1. Is the average rate of change constant? No. In one case, we got positive 1. In one case, we got negative 1. This doesn't feel like a linear function, but to be thorough, let's just do one more. Why are all my colors wrong up here? Let's make this one blue. Is that blue? That's blue. All right, then the last one. If we look at 1, 1 to 2, 4, the change in x going from 1 to 2 would be 1. The change in y, we go from 1 to 4, is 3. All right, so we're going up 3 units. Then what's delta y over delta x? 3 over 1, 3. We can see here that when we pick 2 points from this table, every pair of points we picked gave us a different slope. So this is not a linear function. So we would say the average rate of change is not constant. This table does not represent a linear function. Oop, running out of space there. So we want the rates of change to be exactly the same in order for it to be a linear function. All right, let's look at B. For part B, we have the ordered pairs 0, 10, 1, 15, 2, 20, 3, 25. We can see here, if we just look at, how did I get this color? If we look at the delta x's, from the first point to the second point, delta x is 1, and delta y is, we're going from 10 to 15, so 5. We get that the slope is delta y over delta x, 5 over 1, which is 5. Cool. And actually, that's going to be the same for all of them. We can see here that if you look at any of these 2 pairs, or any pairs of points, I should say, the x values are going up by 1, and the y values are going up by 5. So we have a slope of 5. From 2 to 3, delta x is 1. From 20 to 25, delta y is 5. So in all 3 cases here, we see that the slope would be 5. The x values are all going up by 1. The y values are all going up by 5. That's constant. Life's great. So for part B here, we'll say the average rate of change is constant. This table does represent, or we'll say represents, a linear function. So again, when we're given a table, we want to look at pairs of points, calculate the slope, and we want the slope to be the same. We want it to be constant. A quick way to do that is to kind of show your work on the table like I did here. Look at the difference in the x values, look at the difference in the y values. Also pay attention to whether or not x is increasing or decreasing, so you make sure your signs are correct. If you get the same number for the slope every time, you have a linear function. Or for the rate of change between the 2 points, I should say, you have a linear function. All right, so let's go through C here. For C, it says in C, the average rate of change is it constant or is it not constant? These x values are all changing by 2. So delta x equals 2, delta x equals 2, delta x equals 2, and then delta y is negative 2. Delta y is negative 2. Delta y is negative 2, right. And then when we put that together, the average rate of change, delta y over delta x, is negative 2 over 2, which is negative 1. And that's for all of those pairs, because they all have the same change in x and the same change in y. So yes, it is constant, the average rate of change. So this table does represent a linear function. And here's the key idea here. When we say average rate of change, you can calculate the average rate of change for any table, for any function. It's not always going to be constant. If it is constant, then that means that it's a linear function, and that number that you got for the constant average rate of change represents the slope. Okay, so when we go on to the second part here, write the formula for mx using slope-intercept form. -1 is the slope. So m is equal to delta y over delta x, which is just -1. Also, from our table, we have m is equal to -1. From our table, we see that we have the point 0, 2, which gives us our value for b equals 2. Putting those two things together, what would the equation of the line given by this table be? -1x plus 2. Yes, you can also just write it as -x plus 2. Okay? Yay! So that's a line with a slope of -1 and a y-intercept of 2. All right, now we're going to take a moment to talk about how the slope of a line determines the way that we graph the line. Is it going to be increasing, decreasing, increasing, decreasing, vertical, or horizontal? I'm going to go to Desmos really quickly, and we'll look at a couple of linear functions. If we look at something like the last one that we just had, hold on, let me zoom to a normal setting. There we go. All right, so for the last problem, we had -x, what was it, plus 2? All right, so this is what that line would look like. Notice as we look from left to right, the line is decreasing. That's because the slope is negative. When we have a line that has a negative slope, the graph of the line is going to be decreasing. Okay, if we change this to a positive slope, instead of -x plus 2, we did a positive x plus 2. As you see, the green line there is increasing. We have an increasing line when a slope is positive. And then there are occasions where you might get that either your delta x is 0 or your delta y is 0. In those cases, you get that your slope is either 0 or undefined. If your slope is 0, that means that you have a horizontal line. It means you end up with your delta y is 0. Y isn't changing. So you have a horizontal line. That's something like y equals 3. It's a horizontal line. The slope of a horizontal line is 0. It's not going up or down. Okay. And then sometimes your delta x will be 0. But remember, when we compute the slope, it's delta y over delta x. And then if our denominator is 0, that's a problem. That means that our slope is undefined. When we have an undefined slope, that gives us a vertical line. Sorry about that, you guys. So something like x equals sign 3 would be an example of a vertical line. So let's look at them one at a time. X equals 3, that's an undefined slope because the x values aren't changing. So your denominator for your slope becomes 0. That's a problem, undefined. You get a horizontal line. I'm sorry, a vertical line, When your y values aren't changing, delta y is 0, so the slope is 0, and you get a horizontal line. When the slope is positive, you get an increasing line. And when the slope is negative, you get a decreasing line. All right, and all of that is summarized in the next little table that we have. Restore. All right, here we go. So let's see. If the slope is positive, the line blinks from left to right. It's going to be an increasing line, so it's going to rise from left to right. All right, if the slope is negative, the line falls from left to right. All right, and if the slope is 0, your slope is 0 means the y values don't change. So delta y is 0. That would mean that we have a horizontal line. And last one, if the slope is undefined, that means that delta x is 0 and we have a vertical line. All right, so in the next section, we're going to be practicing finding the slopes, slope of a line between 2 points if we're given pairs of points. But if we are given 2 points, how can we find the equation of the line that goes between those 2 points? Okay, first thing, what is the equation of the line? We are computing, or we want to find y equals, or f of x equals mx plus b. So we need to find m, the slope, and b, the y-intercept. All right, if you're given 2 points, your first step is always going to be to use y2 minus y1 over x2 minus x1, or delta y over delta x to find the slope. So that's what we're going to do in A. We'll call this one x1 and y1, this one x2 and y2. Then then the slope, y2 minus y1 over x2 minus x1, is going to be 4 minus 1 over 2 minus negative 4. 4 minus 1 over 2 minus negative 4. Be careful when you do this. Whatever point you start with for the y's, you have to start with that same point in the denominator for the x's. Okay, so I started with the second point in the numerator and denominator. If we simplify this, that's 3 over 2 minus negative 4 would be 6. So that gives us a slope of 1/2. All right, now we have the slope. How can we find the y-intercept? Well, there's a couple different ways you may have learned to do this. There is another formula called point slope form, where if you're given a point and you're given a slope, you can plug that into point slope form and find the y-intercept. That would require us to know the point slope form though. Some of us might, some of us may not. We can also just use y equals mx plus b. Using, everything's in one color, so it's gonna bother me. So using one of these points, so we'll use 2, 4 for our x and y, and use what we just found for our m as 1/2. We're gonna plug that into y equals mx plus b. Y equals mx plus b would be 4 equals 1/2 times 2 plus b. So you take one of the points you're given, and then you take the slope that you found. From the point, you have an x and a y, and then the slope gives you your m. Plug those things into the slope-intercept form, and then you'll be able to solve for b. We're running out of space here, but that's okay. So this is 4 equals 1 plus b, and then if we subtract 1, we get b is equal to 3. All right, then finally, let's put those two things together. M is equal to 1/2, b is equal to 3. Then our equation would be y equals 1/2 x plus 3. We can double check that. Let's see, if I plug in -4, 1/2 times -4 is -2. -2 plus 3 is 1. That works. And if I plug in 2, that definitely works. So again, our process for this is take your 2 points, do y2 minus y1 over x2 minus x1 to find your slope. And then once you have the slope, use the slope and one of your points, either one, it doesn't matter, and plug those values into y equals mx plus b. So the point gives you an x and a y, and the slope gives you m. And then you can solve for b. And once you have m and b, you can write out the slope-intercept form of the line. So for our first step, we would be calculating the slope. Remember, for the slope, it's y2 minus y1 over x2 minus x1. Notice here that both of the y values are the same. So if we subtract them, 4 minus 4, we just end up with 0 in the numerator. So the numerator is 4 minus 4. The denominator is 8 minus -1. So we get 0 over 9, which is a slope of 0, okay? If we have a slope of 0, this tells us that we have a horizontal line. And the quick way to figure out what the equation is, For a horizontal line, it's always going to be y equals whatever the y coordinate is. Both of these have a y coordinate of 4. It'll be y equals 4. But let's say you forget that. You can use that same process that we used in the last example by picking a point and the slope to show that the equation is actually y equals 0. I'm sorry, y equals 4. So if we use m equals 0 in either of these points and 8, 4, we'd have what's y? 4 equals 0 times 8 plus b. 0 times 8 is 0, so we get 4 equals b. And then the equation would be y equals 0, x plus 4, which is just y equals 4. All right, what about part C? We have the points -3/4, 1/4, and -3/4, 5/4. In the last problem, the y values were the same, and we ended up with a horizontal line. Here, the x values are the same, and we're going to end up with a vertical line. If we calculate the slope, y2 minus y1 would be 5/4 minus 1/4 over x2 minus x1, -3/4 minus -3/4. This would be, in the numerator, we get 4/4, which is 1. And in the denominator, we're going to get 0. What's 1 divided by 0? Undefined. When you have an undefined slope, that tells us that we have a vertical line. And vertical lines are of the form x equals some number. It's going to be x equals whatever the x coordinate is. In this case, x equals -3/4. So this is very important. If you're given 2 points with the same y value, that means y is not changing. So delta y is 0. The slope is 0, and we have a horizontal line. Y equals whatever that constant y value is. If you're given 2 points with the same x value, x isn't changing, the slope is undefined, and we have a vertical line. X equals whatever the constant x values are. All right, then for parts D and E, we're still asked to find the equation of the lines, but we want to find the equation based on the table and then based on the graph. Let's start with part D based on the graph. I just read. If we look at the graph here, first, we should identify the y-intercept. So from the graph, we see that b is equal to 1. And then we can pick 2 points and find the slope, or you can kind of count. We can see that we go from this point to this point. Delta y is 1. Delta x is 2. You can count the number of units you move, the rise over the run. So we're going to go 2 units to the right and 1 unit up, or 1 unit up, 2 units to the right, rise over run. So this gives us a slope of 1/2. Another way you can do it, if you're not a visual person, you want to actually calculate it with the numbers. This point is, what's that, 2, 2? 2, 2. This point is 0, 1. And then if we calculate the slope, m equals 2 minus, what happened there? 2 minus 1 over 2 minus 0. That would be 1 over 2. So we have the line with a slope of 1/2 and a y-intercept of 1. Putting those together, we get y equals 1/2 x plus 1 as our answer. All right, and then on to part E. We can use the table and look at the change in the x's and versus the change in the y's to quickly compute the slope. So here, delta x goes from -3 to 0. So delta x is 3. The y's are 5 to 1. Delta y is 1. For the next one, 5 to 6 is 1. 6 to 7 is 1 for delta y. 7 to 8, 1 for delta y. And then for delta x, 0 to 3, That's 3, 3 to 6. The change in x is 3 again. So for all of these, delta y is 1, delta x is 3. So we get the slope is 1/3. And then we also see in the table that we have a y-intercept at 0,6. So b equals 6. And putting these together, we have the equation y equals 1/3 x plus 6. All right, so if you're given 2 points, you should be able to find the equation of the line between those 2 points. If you're given a graph of a line, from the graph, you should be able to find the equation by identifying, you can identify 2 points on the graph and then use the same steps you use if you have 2 points that are just given to you. Or you can visually find the rise over the run to calculate the slope and find the y-intercept. And then if you're given the table, you should be able to find the equations as well. All right, next part, graphing linear function. Example 3 asks us to graph a linear function given its slope. So graph the linear function with a slope of 1/3. Choose a start point. Use our hint over here is telling us to choose a point to start at. Use the slope as the rise over the run to get another point, and then connect the points and extend them to get the line. So we're not given a y-intercept here. That means that you can draw any line with any y-intercept as long as the slope is 1/3. Okay, I'm just going to start at 0, 0 because that's an easy place to start. 1/3 being the slope means that the rise is 1 and the run is 3. That means we're going to go up 1 unit and then to the right 3 units to get another point. So if we go up 1 and over 3, that gets us to the point 3, 1. We can also go the other way. We can go down 1 and to the left 3. That'll get us another point on the line. And we can continue doing this, up 1/3, down 1, to the left 3. And if we connect all of these dots, that'll give us the graph of our line with a slope of 1/3. So using the slope, once you have a point on the graph, you can use the slope to get to another point on the graph. And once you have 2 points, connect those and boom, you have a graph of your line. Connect and extend. Let's do this again with the equation that's given in example 4. So graph the linear function on slope intercept form, and our function is f of x equals -2x plus 3. So this one's even better because we're given the slope and the y-intercept. So here we see that the slope m is -2 and the y-intercept b, or b, which is given by the y-intercept, is 3. So the y-intercept is 0,3. All right, we can start off by plotting the y-intercept. All right, if we plot that point, 0,3 is here. And then now we can use the slope to find other points that are on the line. The slope is -2, or you can think of this as -2/1. So the rise is actually a fall. We're going to go down 2 and then to the right 1 to find another point. So if we go down 2 units and to the right 1 unit, that's the point we get. Okay, we can do this again. Down 2 units and to the right 1 unit, down 2 units and to the right 1 unit. All right, connecting these points will give us a graph of our line. That's not a good line. There we go, that one's pretty straight. Ta-da! This is the graph of the line f of x equals -2x plus 3. The graph crosses the y-axis at 3. It has decreasing because the slope is negative. It has a slope of -2. All right, let's keep going with these. In example 5, so we started off where we're just given a slope, no point, just a slope, and we were able to graph that line. Then we're given the actual equation of the line, so the y-intercept and the slope, and we're able to graph that line. Now we're given the slope and another point So another point that's not the y-intercept, okay? We're gonna start this one off similarly to what we did in the last problem. Plot the point that we're given, and then we're gonna use the slope to find other points. Our slope again is 1 over 3. So we're gonna go up 1 unit into the right 3 units to find another point. If we plot the point -3, -2, that's here. And then our slope is 1/3. So we're gonna go up 1 over 3. Up 1 over 3. Up 1 over 3. Keep doing this. You can also go down 1, left 3. Down 1, left 3. Well, we won't be able to get to the next point. All right. And then if we connect these big blue dots, we get the graph of our line. So we should be able to not only find the equation of the line, but once we have the equation of the line, graph it. Or if we have the slope and a point on the line, we should be able to graph any point in the slope. You should be able to find the graph. Next, a linear equation can be written as y equals mx plus b, which we've been seeing and we've used a lot. That's the slope-intercept form. Or in standard form, that's another form of the line, we'll have a times x plus b times y equals c. Okay, that's not as common of a way to write it, but you should also know the standard form of a line. In example C, we're given a line that's in standard form, and we're asked to graph that line that's in standard form. We're going to do that by just rewriting it into slope-intercept form and using what we did in the last example. So graph the linear function whose equation is 2x minus 3y equals 6 by rewriting the linear equation in slope-intercept form. We don't have a lot of room at the top, so let's write down here. We have 2x minus 3y equals 6. To get this into slope-intercept form, we want to solve for y. So we can subtract the 2x from both sides. Sure, that'll give us -3y equals -2x plus 6. And then if we divide everything by -3, we'll get y is equal to 2 over 3x minus 6 divided by -3 is -2, so -2. This is the equation of the line in slope-intercept form. Now we can easily see that the y-intercept is 0, -2, and our slope is 2 over 3. Okay, so let's use those. 0, -2 is here. Do I believe that? Yes. All right. And then 2 over 3 being our slope tells us we're going to go up 2 units into the right 3 units. So 2, right 3. And we're going to repeat this. Up 2 units, right 3 units. Remember, we can also go down 2 units, left 3 units. That'll also get us to another point. And then if we connect those points and extend the line, we get a graph of our line. So long story short, if your equation is given to you in standard form, you can write that in slope-intercept form, easily identify the slope and the y-intercept. And once you have those, it shouldn't be too hard to graph the line. I have been doing more than 1 point, but really all you need is 2 points. Once you get 2 points on the line, connect and extend, and that's all you need. All right, moving along. I mean, there's a nice definition here. We've talked a little bit about this already. We've said several times that the y-intercept is where the graph crosses the y-axis, and it's the point 0, b. We also have an x-intercept. That's the point where the graph crosses the x-axis, and that's going to be of the form a, 0. So the x-intercept has a 0 for the y-coordinate, and the y-intercept has a 0 for the x-coordinate. Okay. On to number 7. Another way that you can graph a line, especially one that's given to you in standard form, is by finding the x and y intercept, because it's pretty easy to find the x and y intercept when it's in standard form. So find the x and y intercepts. plot those 2 points, and then draw the line between them. So for 2x minus 3y equals 6, same thing as before. To find the y-intercept, we're going to let x equal 0. That's 2 times 0 minus 3y equals 6. So negative 3y equals 6, and y equals negative 2. X was 0, and y was negative 2. So 0 comma negative 2 is the y-intercept. Let's plot that. Boom. To find the x-intercept, we let y equal 0. So we have 2x minus 3y equals 6. 2x minus 3 times 0 equals 6. That gives us 2x equals 6 and x equals 3. So 3 comma 0 is the x-intercept. And remember, all we need is 2 points to draw the graph of a line. So once we have those 2 points, you just want to extend them. I'm bad at drawing straight lines sometimes. Let me take my time. There we go. Extend them, and that gives us the graph of the line. That's the same line that we had before, right? If we scroll up, you can see that when I did the rise over run thing, we did find that the x-intercept was 3 comma 0. So you can use either method, but this is another quick way, instead of having to write it into slope-intercept form, things might get a little bit messy. If you just quickly find the x and y intercepts, plot those 2 points, that's all you need. You might find this easier than the other method. Finding the equation of a linear function. So find the equation of a line with slope 1/2 containing the point 0, 6. If we're given, so there are several different ways we can be given information and find the equation of a line. Earlier, we said if we're given 2 points on the line, we can find the equation. So we know how to do that. We said also, if we're given the graph of the line, we can find the equation, or if we're given the table that represents the line, we can find the equation. That's 3 different ways. Also, if we're given, obviously, the slope and the y-intercept, that's what we're given here in example 8. That's really easy. We just have the slope-intercept form of the line, we can find the equation. Another way we talked about earlier was if you have the slope and a point, and I mentioned that there was something called point slope form of a line that we can use to find the equation. That's come back up here. So now we're going to learn the point slope form of a line. All right. But for example 8, find the equation of the line given the slope and y-intercept. If the slope is 1/2 and the y-intercept is 0, 6, that equation would be y equals, that's negative 1/2 times x plus 6. Again, because that's slope-intercept form, y equals mx plus b. If we are given the slope and another point that is not the y-intercept, so if you're given the slope and another point on the line that's not the y-intercept, we can use point slope form of a line to find the equation of the line. The point slope form takes the slope m and a point y1, or x1 comma y1, and we have y minus y1 equals m times x minus x1. And once you have this, you can go back and forth between the point slope form and the slope intercept form. All right, so in example 9, find the equation of the line with slope negative 1/2 containing the point 2, 6. So negative 1/2 gives us our m, 2, 6 gives us our x1 and y1. Okay, so using the point slope form, y minus y1 equals m times x minus x1, this would be y minus 6 equals negative 1/2 times x minus 2. All right, then if we simplify this and solve it for y, we'll have this in slope, the equation of the line in slope-intercept form. All right, so let's simplify what's on the right-hand side. We have y minus 6 equals, if we distribute the negative 1/2, negative 1/2 plus 1. Do I believe it? Yeah, I believe it. All right, and then from here, we can just add the 6 to both sides and we get y equals, I missed the x, sorry. y equals -1/2 x plus 7. That's the equation of the line. So again, you use this when you're given a point and the slope, a point on the line and the slope of the line. Plug in the slope that you're given, plug in the x and y from the point for x1 and y1, and then solve for y, and you'll have the slope-intercept form. All right, so for problem number 10, I'm actually going to show you guys 2 different ways we can do this. All right, it says given 2 points, find the equation of the line in slope-intercept form. I'll show you the way that we did it earlier, and then I'll show you the new way that we can do it using point slope. First thing you have to do in either method is find the slope. We have 2, 6 and -2, -6. So m equals 6 minus -6 over 2 minus -2. That's 12 over 4, which is 3. The slope is 3. All right, so if you want to do this using y equals mx plus b, this is the way that I showed you guys earlier that we can solve a problem like this if you're given 2 points. You can find your slope and then use one of the points. It doesn't matter which one. I'm going to use the 2, 6. Plug that 2 in for x, the 6 in for y. We'll have 6, 6 equals 3 times 2 plus b. Something's not right. What's wrong? Maybe it's right. Okay, 3 equals 6 times 2 plus b. 6 is equal to 6 plus b. Then it means b would be equal to 0. So we found the slope, we found b. Putting those together, the equation of the line would be y equals 3x plus 0, which is just y equals 3x. All right, that's if you use the slope-intercept form of the line. We can also do this using point slope. Y minus y1 equals m times x minus x1. It works out similarly. We're going to plug in the 2 and 6 for y1, for x1 and y1. That would give us y minus 6 equals, what was the slope? 3 times x minus 2. And then solve for y. Y minus 6 equals 3x minus 6. And if we add 6 to both sides, we get y equals 3x. So if you're given 2 points on the line, you need to find the slope of the line between the 2 points, so find the slope. And then you can either use the slope-intercept form to find b, and then write it in slope-intercept form with using your b and your slope that you found. Or you can use the point slope form to find the equation of the line directly. So you have some options. Usually I don't care which way you use unless it's specified. If the directions say use point slope to find such and such, then you have to use that equation to find it. All right. The slope of a horizontal line is 0. We already talked about this. And the equation of a horizontal line is y equals b if it goes through the point a comma b. For a vertical line, the slope is undefined. And if it goes through the point a comma b, the equation is x equals a. So for this last little part, it's going on 2 pages. We're asked to find the equation of a vertical line that passes through the point -4, 7. Vertical lines are x equals whatever the x coordinate is, -4. Okay. For a horizontal line, this is going to be y equals whatever the y coordinate is, which is 7. So the horizontal line passing through that point, -4, 7, is x equals -4. I'm sorry, horizontal line is y equals 7, and the vertical line is x equals -4. All right, we're almost done. We've talked about finding the equation of a line given 2 points, finding the equation of a line given the point and the slope. We've talked about slope-intercept form of a line, point-slope form of a line, horizontal lines, vertical lines, finding the equation from a graph, finding the equation from a table. The last thing we need to talk about is parallel lines, and then we'll be all done. All right, so we know that two lines are parallel if their slopes are the same. So two lines that have the same slope are parallel lines. And then we also, parallel lines are lines that do not touch or intersect. So boom, boom, those are parallel lines, okay? If we have two lines whose slopes are negative reciprocals of each other, those lines are perpendicular. Perpendicular lines cross each other and form 90-degree angles. So perpendicular lines basically would look like the X and Y axis look. Boom. Look like this. Okay. So for problem 12, we're asked to take an equation or find the equation of a line that's parallel to the line that we're given, but it goes through a different point. Okay. So for a problem like this, if you're given a line and we're finding a line that's parallel to that line, that means that the slopes are going to be the same. So whatever the slope is for this line is also going to be the slope for our new line. Okay. So we're trying to find a new line that has a slope of 2. And then it goes through the point -3, 2. So this would be our x1 and our y1. You can use point slope form here because we have a point and a slope. All right, that would be y minus y1 equals m times x minus x1. In this case, that's y minus 2 equals, the slope is 2 as well, 2 times x minus -3. And then we just need to simplify this. Y minus 2 equals 2x plus 6. And then finally, y would be equal to 2x plus 8. All right, what does this mean? The line 2x plus 8 is parallel to the line that we were given, 2x minus 3. But it goes through the point, but it contains the point -3, 2. All right, any questions about this one? This is where it gets a little tricky for some people. But the idea here is, if you're told, oh, we're trying to find a line that's parallel to this line, then we know the slope. Whatever the slope is for the given line, that's the same slope for our parallel line. All right, we get to do this again for part B, but in part B, the equation is given to us in standard form instead of slope-intercept form. That's okay though. We can take the standard form and still find our slope by putting it into slope-intercept form. All right, so for part B, we're gonna take 2x plus 3y equals 12 and solve this for y. Put it in slope-intercept form. 3y equals -2x plus 12. And if we divide everything by 3, y is equal to -2/3 x plus 4. Okay. All we're doing this for is so that we can find the slope, because the new line that we're coming up with is going to have the same slope as this line. So our slope is going to be 2/3. So -2/3. M is going to be -2/3. And we're going through the point -3, 2. So that gives us, again, our x1 and y1. And then we go to the point slope form. Y minus y1 equals m times x minus x1. So we can ignore everything from the first equation. Now we're just using the slope is -2/3. Let me make sure I believe me. All right, the slope is -2/3 and our point is -3, 2. So that's y minus 2 equals -2/3 times x minus a -3 would be +3. Then we distribute on the right-hand side and add the 2, okay? Y minus 2 equals negative 2/3 x. Negative 2/3 times 3 would be a negative 2, so minus 2. And then if we add 2 to both sides, the 2's cancel out. So we get y equals negative 2/3 x as our equation. The line that we just came up with, negative 2/3 x, it is, let me make sure I believe it, negative 2/3. Some of those off. Let me double check. So a quick little check here. If we take negative, plug in negative 3, y would be equal to negative 2 over 3 times negative 3. Yeah, that's right. That's positive 2. All right. Sorry, you guys. Had to double check to make sure I didn't make any typos on the problem. Okay. So we're saying that equation that we found that's in the black box is parallel to the original equation we were given, 2x plus 3y equals 12. But the new line contains the point negative 3, 2. All right, and last one. We've made it. This is the trickiest one because now we're looking at, instead of parallel lines, perpendicular lines. And remember, two lines are perpendicular if their slopes are negative reciprocals of each other. What does that mean? So for example, here in part A, we want a line that's perpendicular to y equals negative 2x plus 5. So here the slope is negative 2. So if m is equal to negative 2, I usually use this little notation. M of the perpendicular line, that little sign just means the perpendicular line, would be the reciprocal of this negated. So the reciprocal of negative 2 is negative 1/2, but then if we negate it, we would get a positive 1/2. This is the slope of our new line, okay? This is the one that we want, positive 1/2. And then our line is also going to go through the point negative 5, 3. So let's use point slope form to solve this. Y minus y1 equals m times x minus x1. Our line is perpendicular to the one that's given. The given line has a slope of negative 2. So our line is going to have a slope of positive 1/2. And then we're going to plug in negative 5 for x1 and 3 for y. So this would be y minus 3 equals 1/2 times x minus a negative 5, so plus 5. Then we get y minus 3 equals 1/2 x plus 5/2. And then lastly, to solve here, we need to add 3 to both sides. So we have to add a couple fractions here, but that's okay. Y would be equal to 1/2 x plus 5/2 plus 3. 3 is equivalent to, remember, if you want to add two fractions, they have to have the same denominator. So we can write 3 as 6/2. And then finally, we get y is equal to 1/2 x plus 11/2, 11 over 2. If you want to write this in decimal form, as long as it's a terminating decimal, you can write it that way too. So 0.5x plus 5.5. That also works. All right, and then for part B, we're going to do a similar technique, except we're not directly given the slope-intercept form. So we have to do a little bit of work to find the slope of the given line in order to find the slope of our perpendicular line. All right. So let's start off with the given line. We're given 2x plus 3y equals 12. So 3y equals negative 2x plus 12. Y is equal to negative 2/3 x plus 4. Okay, so the given line has a slope of negative 2/3. Then someone tell me, this looks really ugly. Negative 2/3, is that a little bit better? All right. If this line has a slope of negative 2/3, then what is the slope of the perpendicular line that we are finding going to be? So m of the perpendicular line. What's the negative reciprocal of negative 2/3? So you're going to change the sign to positive and then flip the fraction. So positive 3/2 is our slope. And then that's the hard part. I'm actually going to move this. Let's move that over here because we have more space over here. All right, so positive 3/2 is our slope. And then we're going through the point -5, 3. That's our x1 and y1. And putting that in point slope form, y minus y1 equals m times x minus x1. We get y minus 3 equals 3/2 times x plus 5. And then we simplify this. Y minus 3 equals 3/2 x plus 15/2. And then y is equal to 3/2 x plus 15/2 plus 3. And we just need to add, combine those constants at the end. So we have y equals 3/2x plus 15/2 plus 6/2, which finally gives us 3/2 x plus 21/2.